Yes, they are.
So we're about to get started on Unit 5 in math. Your tests should be coming back to your students soon. I know Annie took hers home tonight. I know Ms. Schoen might still be in the process of giving her tests now, and you're still testing now, but we're all getting to the end of Unit 4. So tomorrow, officially, I will be starting with my 2 math classes, Unit 5. And Unit 5 deals with decimals, it deals with line plots and different graphs, and it deals with metric and customary measurement. Some things that they typically confuse. So we're going to work together to problem solve a bunch of the problems that we would do with the children, and we are going to discuss these particular items in a more clear order. So we've kind of broken up the unit into 4 major topics. Fractions and decimals, we're really just going to talk about tenths and hundredths. And when we talk about tenths and hundredths, we can easily relate that to money. So 1/10 is just like a dime. 1 dime is 1/10 of a dollar. It takes 10 dimes to make a dollar. 1/100th, 1 penny. It takes 100 pennies to make $1. So we talk a lot about that. We compare and order fractions. We're adding fractions. We're going to add and subtract money. We're going to be adding and subtracting decimals as well. The first lesson will be connecting decimal fractions to decimals with just tenths and hundredths. Line plots are tricky. When I was in school, I never learned anything about line plots. This has been part of the curriculum for quite some time now, but I don't ever remember learning line plots when I was a kid. Metric and customary units. We're just going to talk about length, capacity, and weight for customary, and then no weight for metric, and then we talk about perimeter and area, which is a big one. Big one. I have additional advanced topics listed down here, and we will get into fractions and decimals.
All right, so as Kristen said, we kind of translated into money. We have our whole number to the left of the decimal point, and our fractions parts to the right. And we show them with blocks with the grid so they can connect them to place value blocks. We will show them a tenth. We'll get out a, do you have a grid?
I have one.
Block.
I have a poster.
So we'll show them a place value block that looks like this. It has 100 little parts if they were to count them all. And we will take a tens rod and put it on top so that they will see there are 10 tens that make up this 100. Or 1, which will then be 100, that goes on top of the hundredths. And then when we write it, we have our 1, 1/10, 100.
This will soon be hanging up. Same thing.
And then again, we show them the pennies and the dimes. All right, so here we have a half shade or a somewhat shaded grid, and we encourage them the students to count by tens, to recognize that this is 10 instead of counting 1, 2, 3 all the way to 74. We would love for them to be able to say 10, 20, 30, 40, 50, 60, 70, 71, 72, 73, 74. And then sometimes we see difficulties picking up from tens, switching counting from tens to ones. They want to continue counting by tens. So we do see that in some areas. And then we break it apart by the different forms. We have standard forms, which is the regular number. We have expanded form where we break it apart by place value. We have 7 tenths and 4 hundredths. And the 4 hundredths again are these little ones. And then we have word form, 74 hundredths.
Can I add one thing? We are also going to be referring to standard form as base 10 numerals. So that's something to add. This is the Park version of standard form, base 10 numerals. You'll notice it's already up here for our whole numbers as well. And word form, they just talk about this as your number name. Again, it's a little redundant, but they need to know those versions of that vocabulary as well. And even saying tens versus tenths, hundreds versus hundredths, to just keep recognizing that this is part of one whole. That outside box is one whole.
All right, so on yours, the next page, I believe, we have one for you to try. So you have 32 hundredths shaded, and then you can put it in standard form, expanded form, and word form. Base 10 numeral would just be 32 hundredths. And we're trying to get away from the kids saying 0.32 or 0.32.
Are you gonna want them to write the zero if they do that, or just?
Yes.
You want them to make sure they write the zero with that?
Yes. And then expanded form, we would have 3/10 plus 2 hundredths. And then your word form or your number name, you write out the words. 32 hundredths.
Hundredth and tenth, absolutely.
I know, we should.
What's easy for word form or number names is that all you have to do is read the actual number. So you read 32, and then whatever place it ends in, that's what you add. So if there was just a 3 there, it would be 3/10. If it was 32, it's 32 hundredths. For the advanced class, they're gonna go one spot further, and say it says 329, it would be 329 thousandths. That's it.
All right, and then here you can see the tenths and the hundredths, and you can see how they could be related if we took this and put this right on top. So here we have 1, 2, 3, 4, 5 out of how many in all? 10. So our fraction would be 5/10, and our decimal would be 5/10.
If you had a 0 after that, it would read as 50 hundredths, which is the same thing, but that picture only truly represents 5/10 because there are only 10
Right.
equal parts.
Right.
All right, and then for the next one, we have 38 hundredths. So when we have them shade, again, we really want to encourage them not to go 1, 2, but rather 10, 20, 30, 31, 32, 33. And just really recognize 10, I go all the way down, instead of counting out each individual one. And then if we have that in terms of a fraction, we have 32 hundredths. 38 hundredths. I don't know why I said 32. Are there any questions with the grids? It's a nice picture for the kids too.
It's a really concrete way to start.
Yeah. So we move from grids and then we go into number lines. And this should go back to the fractions when we broke up the number line for fractions and we make the rectangle. I know.
This
So-
is where the tenths and hundredths relationship really comes in. If you look at number line A and number line B,
Right.
you can see that they're equivalent.
Yep. Are there any questions about the number line?
I just want to ask one question. It's actually about the number. So if you did 0.3, or you did 0.30, you're just adding that extra placeholder in there. You just want the children to understand that 0.3 and 0.30 are the same exact
Yes.
thing. You're just calling it something different because you've
Yes.
added a 0.
Yes.
Right, yes.
It's just like saying 3 dimes versus 30 pennies.
Mm-hmm.
It's a different representation, but the value is the same. They both have a 3 in the tenths place, even though one doesn't have a 0 there, the other one does. If you put a million zeros at the end of one of them, the value wouldn't change.
Okay.
Number lines are drawing their own, right?
Say that again?
When they make the number lines, they're gonna be drawing their own?
Eventually, yes, or there will be times where they might have 3/10 on this side and 4/10 on this side, and we'll say plot 3 decimals, which is what Mrs. Kimball's gonna actually get us to in a moment.
Okay.
Yeah, the next one. So, like Ms. A said, we give them a number line with 0 and 1, and then they have to plot points in between to understand that there are numbers between 0 and 1. It's not a whole, it's a part of a whole, and they need to be able to see that. So if we were to plot 6/10 on our number line, we would show them how to break it apart, break up the number line into one whole, which would be 10. So I would start them in the middle. and then have them go from there. Can you think of another way to do it, Ms. Guy?
Absolutely, they don't have to label the whole thing.
Would you just have them label?
So they can mark point, like, then find the middle and then just mark
Right,
the
that's
six?
it,
They
yeah.
don't have to make the whole?
No.
Okay, good.
No.
Please help.
We will. There's really no point in doing that. If they know where 1/2 is and they know that 5/10 is half of one whole,
Right.
they don't need to. It's a matter of estimating. We want them to get to a point where they're comfortable with the numbers to do that. That's just like saying down here, this is 2800ths. What are we gonna do? Have them split up this number line into 100 equal parts? No way.
Right.
It would be way too much.
They just need to understand that it's not gonna be
Over here.
closer to 1.
Right.
My recommendation
Similar
for
to the-
this.
It's like like when they were getting to that point with the fraction.
Yes,
It's
yes.
just-
For this, I would definitely have 2/10 and 3/10 labeled and plotted.
so
I
they
always
put
put
the
1/2, and they could then label, 1/10, 2/10, 3/10, 4/10, 5/10.
Right.
And then they could just put a dot where 2800ths would be about on that number line. It would be closer to 3/10 versus 2/10 because 3/10 is 30/100ths. And a lot of the times, we put little dotted zeros at the end of these just to show that
That's
that's
what I
the
was just
same
gonna
thing.
ask, because
Yep.
it's two numbers there, but there's only one there.
Exactly.
Like,
So
knowing my
feel
child,
free to
that would,
help.
yes, we do. Okay. That makes sense.
Are there any other questions with the number line?
So it's just more about estimation when you get into those little numbers like .28.
Yeah.
They don't have to be
Definitely.
specific.
Right.
Specific.
They need to be reasonable, and that's what we try to teach them all the time. Is my answer reasonable? And that takes a little extra patience on their part, which they're reluctant to do, but we push through that. Alright, and then we get into comparing and ordering. So they can use the number line, and we also teach them to use the place value chart to stack their numbers in order to compare. So if we were gonna put 6900ths on our number line, we know that would be closer to 7/10.
And also after the 7/10, you can put that little dotted zero to show that it's equal to 70/100ths.
Right.
So that you know it's just 100th behind it.
Right. Then we would have 6300ths.
Notice where Mrs. Kimball is putting her point on the number line. She's putting it right on the number line where the interval meets the line. A lot of our kids put the dot on top of that interval. It needs to be right on that number line where Mrs. Kimball is putting it.
And then we already have our 6/10. So from here, we can see which decimal is greater, just by looking at the number line. We know that 6900ths is greater than 6300ths, which is greater than 6/10, or 60/100ths. And then if we wanted to put it in a place value chart, if we look at this, we would start at the left, because if we ever had a number in our ones place, that would be the largest one, but we don't have any. So we cross it out and we move to the tenths. And then we see the tenths are all equal. So we can move on to then the hundredths. We have 900ths, 000ths, and 300ths. Well, I know that 900ths is greater, so that means 6900ths is going to be greater. And then we'll have 6300ths. And then least will be 6/10 or 60/100ths. Are there any questions with that? Alright, so if you look at the bottom, go ahead and give it a shot. Hundredths, and that to me is the easiest one to plot, because I know it's gonna be closer to 20 hundredths. And then we have our 1/10 already plotted. And then we can plot our 1500.
So they have to put a dot at the 1/10.
Yes. Just
So
because
wherever
it's
there's a
there, we
number.
definitely need to put a point there, yes. If it's asking you to compare them on a number line, put the plot.
Okay.
We really want them to label the points also. And then looking at the number line, I know that 1900ths is greater than 1500ths, which is greater than 1/10 or 1000ths.
In the advanced class, we're gonna ask them to, instead of put commas, say that this fraction is greater than this, or this decimal is greater than this decimal, which is greater than this decimal.
And then if you wanted to do it on the place value chart, just go ahead and fill in your digits. And again, you start with the greatest place. The ones is the greatest place. We don't have any ones, so we move on to the next greatest place, which would be the tenths. They're all equal, so we move on to the next one, which would be our hundredths. From looking at that, 900ths is greatest. So that means 1900ths is going to be greater than 1500ths, which is greater than 1/10 or 1000ths.
So if the advanced class is going into the thousands, how are they gonna plot that? I mean, what does that,
We probably will stay far away from, number lines for thousandths.
okay,
And just put an extra
Unless,
table.
unless I have everything written here in hundredths, I wouldn't leave it as tenths.
okay,
If I wanted them to plot thousandths, I would have 10 hundredths, 20 hundredths,
okay.
30 hundredths, and if they were gonna plot 154
Right, that's-
thousandths, it would be
yes.
somewhere in here, and it would be 154 thousandths between 10 hundredths and 20 hundredths, because technically that's 100 thousandths and 200 thousandths.
Okay, that's, yeah, okay,
That's exactly what we'll do.
alright,
It won't be quite as in-depth because it's thousandths.
right, that's what I was just trying to picture what's coming from.
We would go from hundredths to thousandths. Yep, great question.
Would you still use the place value chart for that, for
Yes.
thousand?
Place
I
value
actually like
chart.
the
Place value
chart.
chart's gonna be the most helpful
I
thing
was
for
gonna say, I like that
comparing.
even easier, just
Yes.
because it's,
It lets
it's
you
more concrete too,
organize your
whereas
numbers.
them not, right, and making, they're not
Yeah.
missing the mark on
Right.
the normal
Mhm.
number line.
The number line is more to understand the value of the number and where it would
Right.
sit on the number
Mhm.
line. And I think comparing decimals, that we find the most success rate with a place value chart, just because it makes it very clear to the students. And the number line is really just to show them that there are numbers in between
Right.
these other numbers. When I tell them that there's an infinite amount of numbers between 77 and 78, their jaws are on the floor. They can't even imagine this little tiny spot right there, and I tell them that it goes on forever. I'm like, what? Are you kidding? You're lying. So, it's just really for that.
And then we will get into adding fractions. So we have our example up top where they shaded 68 hundredths in one color, and then they continued with 67 hundredths into another color. And they need to be aware that just because you run out here, then you go into another hundredths.
Meaning you have more than one.
Right. So if we looked at this, we have one whole, and then again, we want them to be able to recognize 10, 20, 30, 31, 32, 33, 34, 35. 1 and 35 hundredths. So how many hundredths are shaded in all? We would have 135 hundredths.
Does anyone know how to write that as a decimal?
1.35.
1.35, exactly, and that's all they need to be able to go back and forth as.
I'm like, you're trying to trick
Little
us.
quiz.
And we teach them that when we do have a whole number, the decimal point, you say and.
1 and 30.
So we could do, if we were doing it as a decimal, 1 and 35 hundredths. So then on the next one, you see our denominators are different. We have tenths and hundredths. And this is where it comes in handy, knowing 9 tenths is the same as 90 hundredths. So when we're shading on our number line, or our grid, excuse me, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we have 9 tenths, which is the same as 90, because in each column we have 10. 10, 20, 30, 40, 50, 60, 70, 80, 90. So we can have them dot those zeros again. And then we would need to add on the 1900.
Feel free to use highlighters at the table if you want to use a separate color.
So here we would have 1 whole, or 1 and 9 hundredths.
How would you write that as a decimal? 1.09, good.
And 9
Because there's no
hundredths.
tenths.
Right.
A lot of the times when I'm doing with this with the kids, I'll tell them, if you're not sure, put a line out and just say ones, tenths, hundredths, and label it the way you have it. And that is really helpful too, just to teach that they know their place values.
Are there any questions with that?
I'm only asking because when you turn that into 90 over 100, which makes sense,
Mm-hmm.
and then you add it, you write it as 1 with and 9 100ths. You wouldn't have them write 109 over 100.
No, we would have them, they could write, if they wrote it like this, they would have to change it to that,
Okay.
because they're
right.
equivalent.
Okay. But you want them to look and see that that's. Or,
From the picture,
okay.
yeah.
Okay.
If there's no picture there, then they would probably add them first, get that in
Yes,
proper
okay.
fraction, and then move.
Okay. That's what I was
Yep.
trying to think of. It came separate.
Eventually, we move from the pictures.
Okay. I was gonna say, so this is getting a little bit more complicated when you're doing it this way, so you're gonna, gradually move them into
Yes.
converting the fraction to the, decimal.
Yes.
Okay.
We start the unit with recognizing that 9 tenths as a fraction is the same as 9 tenths as a decimal.
Okay.
So we do that the first day. We do it with tenths and hundredths. So
Okay.
then, yes, by the time we get to here, they should have a solid understanding that 90 hundredths is the same as 9 tenths.
Because some of the kids seem like they already familiar, I'm sorry.
So what I usually teach Janine, it's a cheat sheet. So 9 over 10, right? Like, how would you know that's like 0.90? So what I say to her is to divide 9 divided by 10 will give you 0.9.
Yes.
So that's like 90.
If you do 9 divided by 10, you would get 0.9, which is 9 tenths, which is the exact same thing as,
And then you add plus 19, which will give you, is that right?
plus 19 hundredths. If you did 19 divided by 100 on the calculator, you would get 0.19. You're just converting it. If you do it on the calculator, you're literally converting it into a decimal.
Right.
Yeah.
Which eventually we're going to get to a point where we're saying 9 tenths plus 19 hundredths.
Right.
And then you're just adding them. But they have to understand, again, like Mrs. Kibble was saying, that's 90 hundredths. I always tell them when we're adding decimals, line up the buttons, line up the decimals like they're buttons on a shirt. They have to be lined up. That way you have your ones place lined up, your tens, then you have your tenths, your hundredths, your thousandths. Even sometimes it's cute, we'll draw a little bow tie, just to get them to remember it. It works. Tricks of the trade.
Alright, and then we get into adding and subtracting money. And this is where, if we're subtracting, regrouping comes in, because a lot of times in the real world, you will give a clerk $20, and then you do have to get the change. So they do have to regroup, so they do have to go back and have that solid understanding of subtracting across zeros. You wanna go over this?
I don't think we need to, but don't be surprised if your children come home with a problem that only says this instead of that. They have to know that that's $20 and 0 cents and be able to line it up correctly.
So for time's sake, we're gonna move on past this, because it's really just adding and subtracting
Okay,
money. There's no,
it's just working.
Is that okay with everyone?
that really hasn't changed.
Yeah. All right, line plots. This, I think, is one of the harder things that we teach in 4th grade. There are a lot of really hard skills in 4th grade, but I think line plots are difficult, but hopefully we'll teach you some tricks tonight that will help you assist your child at home. So, this would be a study sheet that they would get. A line plot is a type of graph that plots frequency. So the range is usually very small, meaning the numbers down here aren't very spread out. The difference between 8 and 2 is 6. It's a very small range of numbers. Frequency just shows how much that number is occurring. So this title here says number of steps read by students Monday night. So steps for 100 Book Challenge. A lot of times this isn't even labeled down here. So I like to look at the top and say, okay, number of steps, that's my number line, read by students. Each student is your X.
And what we'll do in our class is we'll turn that X
Into a person.
into a person. So that we
It's easy.
recognize that that's a person.
So that means how many people read 2 steps? 3 people.
That's so cool.
It's just a good way to think about it. So an outlier is something that is way beyond the data, something that stands out. You'll notice that there's a gap between this big cluster of students and that there's one particular student who read 8 steps.
So we say they're left out of the group and they're the outlier.
What does this get them ready for?
Yes, I was just,
Like, what is, like, I don't wanna sound like, what's the purpose of this?
are you gonna say?
I
park?
would love to be able to
Are you gonna say park test?
elaborate. I'm gonna say 1, park. 2, I'm gonna say they have to be able to read any sort of graph
Okay.
and try to interpret it. I can't tell you how many STEM fair projects I got with graphs that
Sure.
I couldn't read because they didn't make any sense.
Sure.
And in real life, they're gonna be seeing different kinds of graphs and they're gonna need to be able to analyze these graphs. They'll see them in textbooks as they get older. They're gonna see them even hanging, say that they work at a marketing company. They're gonna see different types of graphs where you'll have, you know, information for people to look at. Do you have an example?
Yeah, I taught 2nd grade before, and I compared it to Under Armour. They use them to calculate the data that they sell their products for. So like, how many people bought sweatshirts this year, and they would make a line plot. I mean, I try to find real life examples so that the kids will have an idea of what maybe they'll be using them for in the future if they decide to go in that direction. So.
A lot of things we do with this is we try to make it really fun. So we'll play like trash can basketball and we'll see how many they can make it. And we'll generate real data from the kids. And then we'll say, okay, how many students made it? It's very similar to a bar graph.
And they
If
do
you
that a
think
lot
about
in
it.
science, I guess it'll help them in the future.
Yes, it will, for sure. I mean, eventually, this kind of reminds me of a scatter plot. Does anybody remember those?
Those are the dots.
Scatter plots are the dots, and they're all over the place, and then you draw a line in between
Oh, yeah.
just to kind of show where the, yeah, it's, a lot of this stuff, it's just preparing them for more complex graphs, which they will have to look at in statistics classes in the future. It's not the most fun, but we try to make data really fun. So there was one year we were blowing
soap bubbles on our desks and then measuring the diameter of how big they were, so it was practice with measuring, and then we were plotting the data on the line plot, so.
But like,
We
this
try to
is-
make
This
it.
is what's on the park test next month.
Next week?
No,
Next
next
month.
month.
Oh, next month.
Next month.
So how often do you do the park test?
They will do the park test,
Okay,
once
May.
this year. They did it twice last year. One time was in March, one time was in May. They said that
Didn't it feel like it
really and
lasted
truly,
from
there wasn't
March
enough time
till May?
for growth. From March to May, what are they really gonna show improvement on? So, I think that there was a lot of chirping in some people's ears that are high up that just said, we can't be testing our kids this much.
Well, and the testing itself took forever.
It did,
did take
it took
I
a
mean, I
very
know-
long time.
Yes, because of the computers.
Weeks.
Oh,
It
yes.
took weeks.
And it
And by the
restarted.
time we were done, I felt like it was almost 2 weeks later and we were taking it again.
Oh, yeah.
And
I felt
we
like
were all
it was
upset,
taking
what's
it-
the point?
I felt like
you
it
know,
took 3 months.
Yeah.
Right.
Exactly, and, we had our park night last week and Miss Antonius was talking about the data from the park assessment and that we sent those home a couple months ago. We each got a sheet for every single child, just kind of telling you where your child is, and she said, don't worry too much about that because that's the baseline data. This park test is way harder than any assessment that teachers have seen in a really long time. The MSA was much less complicated than this.
Well, and just talking to Annie about it, like, she is very unhappy it's on the computer.
I know
That's
a
a
lot
big
of people
adjustment
are.
for students.
Well, for a couple reasons, because she's like, if the computer doesn't work, she then has to wait for somebody else to finish and then do her work, you know, and then and just having the language art one you sent home, the reading one last week.
Oh, yeah.
It's a lot to read on
It
the
is.
computer
It
and
is.
not have in your hands and,
It is.
you know, that kind of thing, so,
Right, flipping back and forth between pages, you have to
yes,
scroll down to see the whole text.
yes.
It's
So-
very hard.
yes,
It's-
so I know-
Especially since
so
they don't
I-
have
I know.
devices this year, they can't get used to them.
Third graders have had the devices all year long and they have been able to work on the computers. One person
Every
so let's
day.
move into some questions that the kids are gonna have to answer when they analyze a line plot. So number of Panther Paws earned per week by fourth graders. Each X represents one fourth grader. Most of the time it's gonna represent that. There have been times where maybe we will count the number of M&Ms in a bag and each X would represent one bag. It's usually gonna be a person. And these are your number of Panther Paws. So how many fourth graders earned at least 6 Panther Paws? This is some pretty key vocabulary here. At least 6 means at the absolute minimum 6. But it's 6 and up. So we usually would box something like this and say 6 and up so that they would know. And oftentimes, we would then mark off 6 and up and say, okay, well, you're asking how many fourth graders, that means I'm counting my X's, and I can just see how many students have at least 6 Panther Paws, and I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 students, or 14 fourth graders. Really taking the time to look at the question and say, what are they asking for? Are they asking for Panther Paws or are they asking for students? Is really going to help you analyze these plots. How many fourth graders lets me know I'm counting X's. How many Panther Paws lets me know I'm thinking of something else here and I'm not just counting my X's. How many Panther Paws did most fourth graders earn? What do you think we would do for that one? Most fourth graders. If you take a look at the plot, do you see anything that stands out to you? A number that most
6.
students earned.
6.
6 stands out. Most students earn 6 because this is your tallest column. So most fourth graders earn 6 paws.
A lot of times students would see most and say, oh, well, 12 is the most, so it's 12.
Where he wants to know how many X's.
But if
like the
this
most
is saying
X's in a
what's
column.
the most amount of Panther Paws that any student earned, it would be 12.
Right.
What did most students get? Well, most students in the class earned 6 that week. It's a great point.
That's the next one.
So the next one is what's the greatest number of Panther Paws earned by a fourth grader? This would be 12.
This is where they have to really read the question
Yeah.
and think about it as they're reading it, and not just look for keywords and say most, it's this one, least, it's this one.
And this is most fourth graders, and this is the greatest number of applause earned by a fourth grader. So you're thinking about one particular person versus most people in the class. The total number of students, what am I looking for here? I'm looking for all the X's here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 students. And we always encourage them to put students, pause, because then that way they're again making sense of their answers. Are you ready to move on to the next one? Okay. So the line plot below shows the results of a student survey. It says number of siblings of fourth graders. The numbers on the bottom represent 0 siblings, 1 sibling, 2 siblings, 3 siblings, and so on. Number of siblings. Fourth graders are your X's. Number 1 says, what's the total number of fourth graders surveyed? What would you do for that one?
Count them up.
Count the X's. You're just looking for the total number of students that were asked. And again, like Mrs. Kimball said, we can draw little people. Who's a little tighter? A little short, little necks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 students. Who remembers what to do for at least 2 siblings?
Box it into 2 or more.
2 or more.
For this one, questions like this, I've seen students look and say,
Go backwards.
well, they say, oh, well, here's 2 and here's 2, so 2 and 3. They're not making the connection that
Here.
at least 2 siblings, and remembering that the bottom is the siblings.
Mm-hmm. And again, it's asking you for X's, so you've got a total of 5 students who have 2 or more. Number 3 is a tricky one. What's the total number of siblings? Are you counting the X's this time? No. Now you're saying this child here has 1 sibling, this child has 1 sibling, this child has 1 sibling, this child has 1 sibling, and this child has 1 sibling. Which makes this column a total of 5 siblings. There's obviously no siblings here. Here, this child has 2, this child has 2, that's a total of 4 siblings. This is where multiplication facts are going to come in handy yet again. This child has 3 siblings, this child has 3 siblings. It's a total of 6 siblings, and then this child has 5. And you would simply add them together to get the total number of siblings. Again, labeling that line plot, showing what these numbers are, knowing that each X is a 4th grader and that this particular child has 2 siblings. It's difficult. It's our first lesson with line plots, we do the number of letters in your last name. And we put a big number line across the Promethean board, and every child in the room comes up and physically puts their X on the line plot.
It's a post-it note
And
that we
it
give them.
really, really solidifies the fact that the X represents a person. And then when we start talking about the kids in the class, it makes it very clear what we're going through because it relates directly to them. So that's the first one we usually start with. So the total number of siblings, 6 and 4 is 10, 5 and 5 is 10. Total of 20 siblings in the entire class, or the kids who were surveyed. And then write a number sentence that shows the difference between the greatest number of siblings and the least number of siblings. There's one particular child who has 5 siblings. That's the greatest. And then there are several children who have 0 siblings. This is basically asking you to find the range. If there's no data here, which will happen, would it still be 0?
No, it will be 5 minus 1 because nobody has 0 siblings in the class. But sometimes it will be there, and that trips them up. Any questions? They'll get the hang of it. We're not gonna move on until they really understand it. We definitely wanna remind families of that we're really gonna push to make sure that they understand it. If they need another day, we'll keep working through it. So we are gonna have to construct some line plots. The advanced class will have to construct them from scratch. The grade level class will be constructing them based on what's already been crossed off. And you'll notice that here, number of Jolly Ranchers in a bag, each X would represent one bag. The numbers down here is the number of Jolly Ranchers in that particular bag. And you would just cross out. Oops, I'm still on way here. Cross out 51 and put an X over 51. Cross out 42, another X over 42. Cross out 54, and this is something that we don't want to encourage our kids to do. Make their X's different sizes. It can tend to make one column a little bit taller than another when we're really trying to make sure that they're as even as they possibly can be. 53 and 53. And 51. I see a huge gap here. A larger range than typical for a line plot. And we would just have to simply analyze it by saying, what does the X represent? It's not a person this time, it's just a bag of candy. And inside each bag, there's a certain number of Jolly Ranchers. So write a number sentence that represents the difference between the greatest number of Jolly Ranchers and the least number of Jolly Ranchers. What would that number sentence be?
54 minus 40.
54 minus 40. And that just tells you the range of the data. We used to teach mean, median, mode, and range. They took that out. So we no longer study that in 4th grade. One less thing to worry about with line plots. So that's definitely one thing that makes a line plot a little bit more friendly, not having to do those 4 things. Difficult. Alright, so they're also going to have to look at a set of data and understand which line plot represents that set of data. Every time they see a set of data, we're going to ask them to put it in order from least to greatest, and that way they would be able to represent it on a line plot. So I would look up here and I would say to myself, okay, the smallest piece of data is 4. But if I look here, game 1, game 2, game 3, game 4, game 5, do those numbers matter? No, they don't matter because we're just talking about the number of goals scored. A lot of students will get confused with this, but then you could take a peek and look down at the line plots and you'll notice that there aren't quite as many X's marked on the line plots for them to have both sets of data. So, I would rewrite them in order underneath. Put them inside each other's, inside the box here so that I don't get confused.
So you think it's easier to regroup them?
Yes. Only because this now tells me that I have 2 X's over the number 4, I have 2 X's over the number 6, I have 2 X's over the number 8.
It just kind of groups your numbers in an easier way, so that way when you go down to look, the kids,
I can automatically get rid of these 2
Right.
because I only have 1 X over.
if you don't put them in order, the kids will definitely leave out a number.
I know, you just don't think they leave them out I guess they can't really.
If not, if they're Xing them out as they go. If they write them and then go back and X them out, absolutely.
It happens, but it's not the most common mistake you'll see. Really and truly. Line plots are very tricky. So so I look at my line plot here, this only has one X over a 6 and I have 2. So that would mean that this line plot correctly and accurately represents the data.
So do they have to reorder the group? Or just
Every
make
time
it
they
be
see a
that?
set of data, I'm gonna ask them to put it in order from least to greatest, for sure.
You can send.
We will, and I promise,
you will.
we'll go through and we will count with them, we'll make sure, we'll say, okay, how many numbers were there? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers did you just rewrite? 1, 2, 3, 4, 5, 6, 7, 8, 9. And if it's not 9, they have to go back and find it. It's all about being precise. It's one of the mathematical practices. We need to get the kids to attend to precision. The math office is just loving that right now.
The math office.
All right, so let's talk about metric versus customary units of measurement. Customary units of measurement are what we use here in the United States. Metric units of measurement are what a lot of other countries use. So I think that the metric measurement piece is a lot harder for the kids and also parents. I mean, I had a hard time with metric measurement when I was doing this for the first time because I hadn't seen it in forever. So they do need to be able to convert from feet to inches, from yards to feet to inches, and things of that nature. So let's see what you know. 1 foot is how many inches? 12. 1 yard is how many feet?
1 yard?
1 yard is 36 inches, but how many feet is that?
Oh, I'm sorry, 3 feet.
3 feet. Anybody know how many feet there are in 1 mile? Ms. Easer?
5,280.
5,280.
Sounds like a Jeopardy question.
Denver is a mile high, so one says 5280 on the time.
Oh. You need to tell the kids that because they will know. I'll know that forever now.
And then for yards, an easy way to determine this, if you're grouping your feet into groups of 3, 5,280 divided by 3. Yay, division! We know you missed it. We're trying to bring it back on the homeworks and keep it alive.
Yes,
Students come up to me and say, I forgot the area model for division. Will you put that on a homework? I said, you betcha. Who said that? Braden. You can get it.
1,760.
Exactly. Just the way we taught them.
Yeah, I don't do it your way.
I know you don't, it's okay.
But she did tonight, so.
One 1,760. I know, you don't have, just do it the way they know how to do it this way. I don't want to take the time to walk through it now since we already had that paragraph a couple months ago. I don't want to make you suffer again through it,
I
but
just don't go that way.
Right.
It's just kind of building it backwards. So
yeah.
it's really all.
So, here's your key. We just did it.
Keep that.
There you go. Your kids will get this as a study sheet. This will be in the math notebook. Yes, it was there the whole time.
I know. Didn't even notice. Read ahead.
Just trying to quiz you.
Not on task. Staying with them.
Exactly.
You should be reading ahead.
So they will need to be able to recognize the relationship between feet and inches. And here it is pretty easy to see. We talk to kids about function tables all the time. What would you do to 1 to get to 12, 2 to get to 24, 3 to get to 36, and then so on. This is tricky for them here because if you jump to another number, they automatically just assume that that's 5.
Right.
They have to pay attention. If you know that 1 foot is 12 inches, then 2 feet is 24 because you're simply just adding another group of 12,
Right.
which is multiplication. So 4 times 12 would be 48 inches, 7 times 12 would be 84 inches. I expect you all to know this. You'll be up here teaching with us. All right, ladies? Anita's like, what?
She's like, she's not talking to me.
What? So let's see what you guys can do. Measurement is something that we typically know and use all the time. So see if you guys can figure these out. at your tables. Inches, work with a partner. And you add 4 inches, that's a total of 40 inches, which is less than the height. So no, she is not tall enough. Very nice job.
No.
Latanya used 6 yards and 1 foot of ribbon while wrapping presents for her son's birthday party. How many inches of ribbon did she use? So, 1 foot is easy. I know that 1 foot is 12 inches. But what would I multiply each yard by to figure out how many inches are in 1 yard? Or in 6 yards? Multiply by 36. If I know that 1 yard is 36 inches, that means that 6 yards is 6 groups of 36. So you would do 36 times 6, and what did we get for that? 216. Add them together, and you'll get your total number of inches. Just have to convert back and forth. This isn't huge on Park, but I think it's big in life. They need to know this stuff. We spent a little extra time on telling time, elapsed time. They need to know this stuff for life. You need to know how to read a clock. All right, capacity and customary units. So this is talking about gallons and quarts and pints and cups and all that fun stuff. When I was in school, I was not taught the gallon land strategy, and the gallon land strategy is one of the best things I think you could ever use to teach a child what capacity is all about. So capacity is the amount of liquid something can hold. We teach them this adorable little story about the land of gallon.
And I use it when I am like taking recipes from Pinterest and need to figure out what I need to buy. I like remind myself of the story of Gallon Land when I'm in the grocery store.
Exactly. So we tell them that there's 4 queens who come to the land of gallon, and we draw 4 big Q's, and those Q's stand for quarts, meaning that there are 4 quarts in a gallon. Then we move on in the little story, and we say that one day a group of princes and princesses come along, and each queen took in 1 prince and 1 princess to take care of them, which shows us that there are 8 pints inside of 1 gallon, but inside of 1 quart, that's the same thing as 2 pints. So this visual really and truly helps. Next, we say that 16 children came along. Each prince and each princess took in 2 children. So 1 pint is equal to 2 cups. 2 pints is equal to 4 cups. 1 quart is 2 pints and 4 cups, all the same. I know it might seem confusing now, but the kids really, really hold on to this strategy, and it works.
Right there.
Put it on the fridge. So this is just a chart for you guys to use when you guys are helping your children at home with homework. You've got a little answer key there to assist you. And then we can go ahead and try it together. So let's try to draw the land of gallon. What came first? 4 what? Quarts. 4 quarts or 4 queens?
Oh, that's a blue hue, I guess,
Yeah.
right?
Yeah.
Uh-oh, my one little topper a little bit.
It's gonna drive Missy crazy.
It is.
Yeah, it
I
is.
might have to redraw that.
No, let that one go. Let's see if you can do it.
All right, I can do it. And then how many pints are inside of 1 quart?
These are your princes
2.
and princesses.
Yep. And I try to make
That's
these
the
extra big, because I know I have to fit the children inside.
I'm catching on now.
It's really fun doing it in different colors too. It's the child in me.
See, this is my question about the not necessarily trying to go back to Park, but they do so much. They do everything pen and paper, like their
Yeah.
area models, all that.
Yep.
We were
They will
talking-
get scrap paper.
We're teaching them to
Do
solve
they
it
have to do
on the
Do
paper.
they do area models on the computer?
There
Or
might
do
be.
they solve it on the paper and then just put the answer? Do you know what I'm
They
saying?
can solve it on the paper and put the answer in. If there's an area model on there, it'll be there and it'll have the blanks and they'll have to click in each portion of the area model to type in the numbers. Or it'll say, look at this student's area model and find their error.
Okay.
So then they should solve it on their paper in order to tell them what the error is. The whole point is for them to solve it on the paper in front of them and then type what happened.
These are not very nice.
And then we have 2 cups inside of each pint.
Or 2 children.
Or 2 children.
Prince and princess.
So 2 quarts, based on the picture, is how many pints? If I look at 2 Qs, how many P's are in there? 4. 3 gallons would be how many pints? Well, 1 gallon has how many?
4.
1 gallon is 4 pints, so it's 12.
1 gallon has 1, 2, 3, 4, 5, 6, 7, 8 pints. So 3 gallons would be 24 pints. Five cups wouldn't be an even number of pints. It would be a certain number of pints with some left over. If I see 5 cups, I could even say to myself, just draw the cups here, I know that that's 1 pint. Draw the cups here, I know that that's 1 pint, and here's a cup. That means that I have 2 pints and 1 cup left over. So they don't even have to draw the whole gallon land, they can just draw what they need. 2 quarts. Here are the quarts. 4 pints right there. And they would draw that model. It really works, I promise. And I remember it now. I never really learned this when I was a kid. 7 quarts and 1.5 gallons. 1 gallon is how many quarts?
4.
How many cubes do you see? 4. So if 1 gallon is 4 quarts, what would half a gallon be? 2 quarts. So that's saying 4 quarts plus 2 quarts is a total of 6 quarts. And then we would know that 7 quarts is greater. And then 2 gallons versus 9 quarts. If I know that 1 gallon
4.
is 4 quarts, then 2 gallons would be 8 quarts, and 9 quarts would be greater. I love Gallonland. It's so fun. The kids love the story too. We read it, we get all dramatic, and you know, might as well put on royal music, and they get so into it. They really do. Are we all good to move on from this slide?
Yeah.
Yes?
This is gonna take practice.
It will, but I promise it will be okay. I know, and remember, we are jamming all of Unit 5 into your head in an hour and 15 minutes. Yeah, so that's why we want you to go home with these and be able to use them again. I hope that you have found these things useful and helpful when you're working with your children at home.
How long does Unit 5 does it take you to get through this?
A month? Maybe a little less?
I think this year Unit 5 is a little different than it was last year.
How many math units are you supposed to get?
6.
Okay.
And we will get through them all,
Yeah.
for sure.
Several years ago, I think there were 12
There were
math
12.
units. So they condensed them majorly.
Multiplication used to be split up from Unit 3 to Unit 5. It was all Unit 2 this year. We went from multiplying basic numbers all the way to multiplying 2 digits that are down in the corner that they can click on that might give them this first bit of information. So being able to go on to the computer-based test, being able to reference those tools with your child will then assist them if there is a reference table available, and if this so happens to be there.
It's just interesting because
Thank you, a Loyola intern. See, Loyola, they know what's up. Loyola grad myself. Making that mistake up here. Everyone with me, moving on.
Yes.
Forgetting that mistake.
Move on.
Edit.
So what would beg more, 36 ounces of string beans or 2 pounds of broccoli? You're comparing the measurements, aren't you? 36 ounces compared to 2 pounds.
Fun.
We said 1 pound is 16 ounces, so 2 pounds would be... Not a reading teacher. 2 pounds would be 32 ounces. And I know that 36 ounces is greater. At the doctor's office, a baby girl weighs 28 ounces and a baby boy weighs 1 pound 10 ounces. Which baby weighs more?
Girl.
I always suggest taking your pounds and going to ounces. It's harder to combine your ounces to pounds. So I know that 1 pound is 16 ounces, plus the 10 ounces gives me a total of 26 ounces, and therefore the baby girl weighs more.
And they can abbreviate?
Yes, absolutely.
You're not thinking about the practice. I'm just more impressed about
I'm sorry, I'll go back. I just feel bad at 7:30. I'm out of the way.
I'm not with my children, so it's okay. I'm joking. I know, my niece is with them, I'm not kidding.
Thank you, ladies.
No problem,
Thank
thank
you.
you so much. Okay. So 3 tons would be how many pounds? If 1 ton is 2,000, 3 tons would be 6,000. And then I have to go backwards. 8,000 pounds is how many tons? 4. And what would weigh more? 5 tons of basketballs or 12,000 pounds of tennis balls? 5 tons is how many pounds? If I know that 5 groups of 2,000 is 10,000, I can see that 12,000 pounds weighs more than 5 tons. Just mention when it's close tomorrow. And metric, woo!
Yay.
All of Unit 5 in one night. Are you ready to teach tomorrow?
You're up.
Are you ready to teach tomorrow? Are you guys ready to teach tomorrow?
So for metric measurement, we have meters, millimeters, centimeters, and kilometers. And then we have 1 centimeter is the same as 10 millimeters. 1 meter is the same as 100 centimeters. So 3rd graders made a car for Safe Racer. They raced the cars in the hallway. The distance was measured in millimeters. Marcus's car went the farthest, 36 meters. How many centimeters did Marcus's car travel?
I know, meters, centimeters, centimeters, meters.
So if we're taking 36 meters and trying to turn that into centimeters, we know that there are 100 centimeters in a meter. So we have 36 meters times 100 centimeters will give us a total of 3,600 centimeters. They can box their basic fact for multiplication. 36 times 1 and next to 2 zeros. There are 1,000 milliliters in 1 liter. So the metric system is based on 10, 100, 1,000.
And they're gonna have to think about metric versus customary in terms of a gallon versus a liter, and a milliliter versus a cup. Just have to understand that those are the smaller units of measurement.
So if 1 liter is equal to 1,000 milliliters, how many milliliters is equal to a 2-liter bottle? Two liters would be how many milliliters? 2,000. Multiply by 1,000. If there are 3,000 milliliters in a container, how many liters of liquid are in the container? So this time we're going backwards. So again, if we have 1,000 milliliters in 1 liter, if we have 3,000, how many liters are we gonna have? 3. So it's really just converting and then thinking, is it reasonable to measure this bottle with which one of these measurements would you use? And then we get into perimeter and area, and luckily this has not changed.
Yay!
So the perimeter we teach them is, we look at the rim or the outside of a figure. We talk about the outside of the Promethean board. We have students stand on the perimeter of the carpet. They stand on the outside to recognize where they are. And to do the perimeter, you just add all the sides. So find the perimeter of the first figure. We would just add the sides.
If they already know that 12 plus 12 is 24, they can simply write 24. Just cut it down.
Anybody have the answer?
I'm sorry.
37? 37 what?
Good.
We really want them to put those labels on all of their measurements. And then for the square, we only have one side labeled.
Look at all this.
Right, because on a square, all sides are the same. So,
And for that, are we gonna
4?
say 8 plus 8 plus 8 plus 8?
32 what? Hopefully that's the same way you guys learned it. Nothing crazy there. They will see some different figures that are all sides are labeled, so they just have a lot of numbers to add up. All right, and then we have the area. The area is the space inside a figure.
And we've been talking about area all year long with the area model.
Right, find that inside space. So we teach them area is length times width. So if we have a rectangle, we would multiply 5 times 3 for a total of 15 feet. I believe in, do we do any counting of the sides?
What?
Do we do any counting of the, they can see, if it's on a grid like this, they can see that it's an array.
But this is like that test part question that came home the other night on the back of the math homework.
But that was a very complicated area
That's because they
perimeter
can't,
question.
and it's very.
They can't overlap, and they have to notice that those little black
Right.
boxes were overlapping.
Plus, sometimes I feel like they put so many words in a question, it's meant to.
Yes, we went over that question as a class because a lot of friends had difficulty with that.
And then again, if you're finding the area of a square, you might only have one side labeled because all sides are the same. So 10 times 10,
You wouldn't believe how much students confuse area and perimeter. This is something that you really want